Here, we present XMP-Font, a few-shot Chinese font generation method. Generating a new font library is a very labor-intensive and time-consuming job for glyph-rich scripts. Few-shot font generation is thus required, as it requires only a few glyph references without fine-tuning during tests. Existing methods follow the style content disentanglement paradigm and expect novel fonts to be produced by combining the style codes of the reference glyphs and the content representations of the source. However, these few-shot font generation methods either fail to capture content-independent style representations or employ localized component-wide style representations, which is insufficient to model many Chinese font styles that involve hypercomponent features such as intercomponent spacing and connected stroke. Typically, a font style involves unique morphological structures of a font at multiple scales. For example, stroke level styles involve stroke level features such as weight, hollowness, and serifness. Component level styles implies how strokes are oriented and joined to form a component. Character level styles engage character level features including the component layout, intercomponent spacing, and connected stroke. First, let's look at a set of results. A complete Chinese font includes tens of thousands of Chinese characters, hundreds of different Chinese character components, and completely different arrangements and combination methods. Because Chinese character fonts have strict requirements on the number, position, and frame structure of strokes, general image translation models do not have a deep enough understanding of Chinese characters. The frame structure of fonts is also an important type of style information. For some more difficult tasks, such as calligraphy font repair, or when there are only a very few number of reference characters, the success rate of previous font generation methods is really low. So using same 4 characters with different fonts as reference, XMP-Font is able to transfer an Asian Chinese poet to look very similar to the reference font. The training of XMP-Font is divided into 2 stages. First, pre-training stage. Pre-train a bird-based cross-model feature extraction model and use the reconstruction loss and stroke prediction loss to ensure that the extracted font features can be extracted without losing information. Fully understand the relationship between strokes. In order to enable the model to understand the relationship between the pictures and corresponding Chinese character stroke order, we train on a large dataset with the following tasks. First, predict the stroke order that is covered. Second, image reconstruction. When the pre-training phase is completed, Chinese characters in any font can be perfectly reconstructed, and the overlaid stroke order prediction accuracy rate can reach more than 80%. Second, font generation stage. The features of source domain word and the reference word are extracted respectively through the pre-trained feature extractor, and the decoupling and recombination is performed to finally generate the source domain word with the same font as the reference glyph. In this phase, the encoder of the pre-trained part is fixed, and only the decoupled network and decoder are trained. We also propose a novel stroke loss based on a pre-trained LSTM-based stroke order predictor to enforce the correct stroke order of the generated glyph instead of the existence of stroke labels only, which proves to benefit the structure preservation and faithful generation of stroke order related style features, for example, connected stroke. Due to the size of the font domains defined by the appearance features of multiple scales, measuring the visual quality with a unified metric is a challenging problem. In addition to ground truth-based metrics, we also use evaluation metrics that does not require paired ground truths. Other than the objective metrics, we conduct a user study for quantifying the subjective quality. We observe that XMP-Font outperforms other methods in both seen and unseen font generation scenario for most evaluation metrics. In the unseen domain scenario, ours exceeds others in all metrics by large margin. Especially, our method achieves a remarkably 28% high success rate on unseen font domains over the second best. As shown in this figure, the blue and red boxes highlight the bad cases. The advantage of our XMP-Font is highlighted with more successful transfer of styles of all scales. XMP-Font preserves both the detailed local style and fine-grained global styles, and generates the plausible and recognizable images consistently. Such a noticeable gap in visual quality explains the large performance leap of XMP-Font in the user study. We use unseen fonts as reference fonts and found their nearest neighbors in the training set, and compare them with the generated results. This verifies that our method does not overfit the training data. The fact that a single glyph can produce good results with our method is the advantage of our XMP-Font. Indeed, it is difficult for a single glyph that is too simple to fully represent the whole font library. It can be observed that using more reference characters makes our results more robust. Finally, let's look at the generation effect of 3 different sets of generated fonts on the 3,000 most commonly used Chinese characters. Thank you for listening.